Okay, so last time I showed you how to build an Anvil app and let Anvil host it for you. This time I'm going to show you how to build an app, deploy it to a Raspberry Pi, and self-host it, and actually do some things that you can't do if you're hosting on Anvil, and actually use some, in this case, Raspberry Pi specific functionality in the app. So here's an example I built. So it's really simple actually, but it basically shows you retrieves the model number of the Pi that you're running on, the revision code, the host name, the current CPU temperature, and what it's also doing is logging the CPU temperature every minute as a background task, storing that in a database and showing you the last 24 hours of data on this graph, which is quite dull here as it's just been sitting around 45 idle. And I've also added a little button that you can click that just tells you a joke. So that uses the PyJokes library, which I've installed on the Raspberry Pi, which is something that isn't pre-installed on the Anvil instances. So you can see here that this is hosted on a custom URL, so it's anvil.hostedpi.com. So that's live on the internet, but not hosted by Anvil. It's completely offline. And if Anvil were to shut down at some point, this would still be running. I've still got access to the entire sort of source code running on my Raspberry Pi. So let's start building the app. So here is the Anvil homepage, anvil.works, and if I click Start Building, I'm logged in. That's going to take me straight through to my apps. So I'm going to create a new app using Material Design. I'm going to rename that to Pi Temperature Demo. So it's going to be a single page app, so I'm going to leave that as form 1. I'm going to start by adding a label for the title of the app, and I'm going to call that Raspberry Pi Temperature Demo. So like the app I showed you before, I'm just going to have a grid of text labels with for each of the components that I want to show. So I'm going to start by making that grid. So I'm going to have 2 side by side, so there's going to be an actual label here, and then the text content will fill the space of the label there. And I'll do that for each of the things that I want to show. So I'll just make those. Oops. So you just drag them in and place them side by side. Okay, so I've got those, and I'm going to enter the text of the labels that I want here. So I'm going to have the model there. So that's going to be the Raspberry Pi's model name. I'm going to make the labels, I'm going to make those subheadings, so they're a little bit bigger. So this one's going to be revision code. Just some identifiable information about the Pi, just to show sort of for real that it's what it's doing. So the third one is going to be host name. Make that subheading. And the fourth one, CPU temperature. And then for the labels, I'm not going to fill these in with text right now. They're going to be populated dynamically. So because they're going to be used in the code, I'm going to use the label names. So I'm going to rename these. So model, revision, host name, and temperature. So then I'm going to have another component underneath. That's going to be a plot. So this is the plot. So I'll drag that underneath all of these boxes. And then I'm going to have a button at the bottom. It's just a little Easter egg that I'm going to have to make it tell me a joke. So let's have get joke. And we'll just say joke in there. Align that to the right, make it primary. It's just a nice little button at the bottom. and that's it. So let's have a look at that. This is just a completely static, unpopulated version of my app. So I've got my 4 labels there that I've made with appear slightly bigger. I've got my button at the bottom, and here is the space that the plot is going to go. There isn't any data being passed into the plot at the moment, so it's not going to do anything, and there's nothing in the text labels here. They're all empty. But the basic premise of the app is set up. So now what I'm going to do is, because I can't actually fill these text boxes with real data from the Pi because it's not running on a Pi yet, I'm just going to add some dummy data, some mock functions that will fill these, and then I'll replace those when they're on the Pi side. So if I go to the code, so I'm going to do all this on init, which means when the form loads. So inside here, I can say self.model, and that's a component, so .text, and I can set it to something, so I can say model goes here. Let's just run that to check. Yep, so it's filled that directly with the string I passed in. But actually what I want to do is run that as a function on the server side, even though it's not really going to do anything yet. I'm just going to make that extra jump. So I'll define the function on the server side. So click on server code, add a new server module, and then again all this stuff here in yellow is the server code that's going to be run on, in this case, on the Anvil server. But when I deploy this to the Pi, it's actually going to run on the bare metal of the Pi itself. So I'm going to uncomment the example they give you. So this is decorated with anvil.server.callable. They've given you a function called say hello. I'm going to make this get model. I don't want it to take any parameters, and I'm going to have mine return some model number. Okay, so I now have a server callable function called getModel, which just returns a string, but at least it's actually a function that's running on the server side now, as opposed to just being set directly as a string here. So then I'm going to say anvil.server.call. I'm going to call my one server function, getModel, and whatever the return value of that will be set to the text. So it's very, very similar to what I just had, where it's just a static string. Now it's calling the server and returning a static string. So if I run this, text is going to be slightly different from last time, but it's coming from the server side. Some model number. That's what I asked my function to do. Okay. So now for the other ones, I'm going to want some similar functions. So I'm just going to copy paste this. I'm going to have one for the revision code. Get revision code, get hostname, get temperature, and that'll do for now. So we've got and then I want to fill these in, so get rev code, get some hostname, and some temperature. So go back to my form and do the same again here. 1, 2, 3, 4. So self.model is going to be self.revision, self.hostname, self.temperature. These are going to be get temperature, get hostname, get revision. You've got to be really careful when you're doing copy paste like this, because it's very easy to copy paste 4 times but only forget to replace one of them. It's a very common programming problem, but I think I've got them all there. So what I've done here is for each of these attributes of the form, so self.model, self.revision, remember those are the these 4 boxes here, so they're just text labels, but their contents are being populated dynamically, unlike these ones which I've just written in. So if I click on model there, text is just the word model and a colon. And then in model here, the text is empty initially, and there's nothing in here to indicate where it's getting it from. It's all done in the client side code on init when the form initializes. And each of them is calling a server function, and whatever the return value of that is, setting it to the text property of the component object itself. So let's run that, and we should have 4 static values, but coming from the server side. So we've got some model number, we've got some revision code, some host name, and some temperature. My button down at the bottom isn't doing anything, I haven't told it to yet, and my graph isn't being populated, but we can get onto that next. So now I want to add an event. When I press the button, I want it to show an alert, a JavaScript alert, which will show me the joke that I asked for. So first of all, if I click on this joke button here, I call it get joke. I actually want to rename that to joke button. And then on click, I want it to fire an event, which will be a function on the client side. And that's going to be called, I'm going to call that one get joke. So if I click here, that will create me the function that I'm going to use. So this is the event callback. It's actually a method of the form. So if in here I say alert, I could just say hello for now. So now this method, getJoke, is tied to the event of this button being pressed. So if I run it now, run the app, and I've got my strings that have been populated here. Click joke, I've got my alert that just says hello, and that's it. But it just does the same thing every time, it's just the word hello. That was a client-side function. So what I'm actually going to do when this is deployed to the Pi is that's going to be run on the server and call the library that I'm going to install. So I will make that a server function as well. So just copy and paste that one and make this one get joke and some joke. Then in my form, I'm going to replace, in the code, I'm going to replace hello with alert joke. But joke is going to come from the server. So I'm going to say joke equals anvil.server.call getJoke. So whatever the server function getJoke returns, it's going to show that in the alert instead. Let's just test that. Joke, some joke. So that's come from the server side this time. And then I just want to test the plot. So if I go back to design, I've got this plot area here. So I know that's named plot1. I'm just going to change it to plot temperature plot. Okay, so I've now got a plot in here called temperature plot. And in order to be able to populate that with data, I'm going to need to be able to call a server function, which will retrieve the data. So I'm going to need a server function in here that will retrieve the data, but I also need to have stored the data in a data table. So first of all, I'm going to need to create the data table. So if I, under services, click add, data tables at the top. I'm just going to make a simple single table database with 2 columns. So this is going to be called temperatures. So apptables.temperatures, and it's going to have 2 columns, a date and time column called datetime, and a number column for the temperature. So every time I get the temperature, I log it in the database with the timestamp that it was collected and the numeric temperature data. So I'm going to need, first of all, a function that actually inserts the temperature. So that's going to be a server function. So I'm going to have a function called save temperature, and that is going to add a row to the database. So apptables.temperatures.add row, and that takes the date time and the temperature. So I'm going to retrieve the date time just using the Python datetime library and read the temperature as well. I'm not going to be able to do that for real on this side, but I'll mock that here. So first of all, I will import datetime. So from datetime, import datetime. That will allow me to do datetime equals datetime.now. So the good thing about the data tables in Anvil is that the datetime, the type of the datetime column is a Python datetime object. So I don't need to turn it into a string or do anything strange or pass it in a tuple in a particular way or anything like that. I just pass in datetime.now, and that's all I need to do. So the other parameter was datetime, so temperature. So that's the second column. So temperature, and I'm just going to pass in an arbitrary string for now. So I'm going to pass in 50. So I'm going to store that every time I want to initially, for the purposes of getting the demo going, I want to store this every time the form is opened, and later I'm going to change that to be a background task that runs every minute like a cron job and just saves into the database. But for now, just so we have some data so that we can get it back out, so that we can plot it, I'm just going to store 50 and make sure that that goes into the database. So now back to the form, and when the form loads, it runs the init. So in here, all I want to do is I don't need to save this or anything. I just want to run anvil.server.call and call my save temperature function, and that will save it when the form loads. So if I run the app now, it's going to show me my data, my fake data. If I stop that and have a look in the data tables, you can see there's now added one row. So we've got the date time, so that's the current time, so 31st of May, 1425. And we've got the temperature 50, the arbitrary temperature that I wrote in the function. So now currently every time I run the app, it saves a new temperature. Now back to the server module. So I want a new function that retrieves the data from the database, so that I can call that from my form and be able to have the data that I need to be able to make my plot. So I want another callable function. This one's going to be called get temperature data. So first of all, to be able to retrieve the data, so I just want data equals apptables dot temperatures dot search, but with no parameters. So just retrieve all the rows and send them back. So I've got that data, but I want to break that up into two lists because I want my x-axis data and my y-axis data. So it's going to be the timestamps and the temperatures. So if I say times dt's equals, then I want a list, and I'm going to do something. I'm going to do list comprehension. So I'm going to do d for d in data, and then I want d. And you can see here, even though it's a list comprehension, it's managed to get the scope of and the introspection of the data there. So it knows that d is one of my items from data, which means each d is a row from the database, and I can index the row object on the column. So for each row result has a date time and a temperature. So I want date time there. But I want this to be a string, so I'm going to say string of this, and then I want temperatures the same. So I'm going to copy this line and make a new one for temperatures. So temps equals, I don't want this to be a string, and this wants to be d temperature for d in data. So now I've got two lists. I've got my string representations of the timestamps in one list and my temperatures in another. And then I just want to return both of those. So I'm going to say return this as a tuple, so DTs and temps. So now from my form, from my client-side code, I can call this function and retrieve the data in the way that I need it for the plot. So back to the form, and again on init. So when the form loads, I want to grab that data so that I can plot it. So we'll say DTs and temperatures equals anvil.server.call, and that wants to be get temperature data. And then for now I'm just going to print that. So I'm going to say print temperatures. But first of all, I'm just going to go back to my server and I'm going to change this to 51, just so the second time I run, I've got a slightly different data point to go in. So back to my form, and I will run that, and we should see 50 and 51, so that's what I expected. So it's now set, just on that load, it saved the new temperature of 51, and all I've done is retrieve it, and I've printed out just those two values, or all of the values it returned. So if I go back, and I'm just going to be really wild and change that to 52, so that next time it's going to go up a little bit. So instead of just printing them, I know I've retrieved them successfully. So in here, I'm going to create a scatter plot. So they provide you with so plotly graph objects is aliased as geo. So I want to say temp equals geo dot scatter, and that's going to take my x, which is going to be DTs, my y, which is going to be temperatures, and I'm going to name the plot as well, so I'm going to call that CPU temperature, and just tidy that up. Okay, so I've got my scatter plot, but that's not going to do anything yet. I need to add that scatter to the plot. So in self.temperature plot .data, that takes a list. So you can create multiple things like scatter plots and add them and make a list of them and add them to the data for the plot. But because I've just got the one, I'm just going to do that. So just pass in a list containing just my scatter plot. That should be enough to plot that, and when I run it, it's already got the 50, it's already got the 51, should add a 52 and plot all three. So there you can see I'm not printing anymore, so that can go away. So I've got my 50 there, I've got my 51 and my 52. Now you notice they're not evenly spaced apart due to the amount of time that I spent between running it each time, but that seems to be working. So I don't really in the end want to be saving it every time the form opens, because they're going to be sort of random. There's going to be random intervals of between data points. As I said, I'm going to want to run that as a background task and have that run regularly. But that will do for now. It seems to be working. So whatever is in the database, regardless of how it got there, it's going to be able to make a graph out of it for me. Okay, I'm going to show you how to use the Mythic Beasts Pi cloud to provision a Raspberry Pi 3 server, which you can access over SSH and deploy web apps to. So Mythic Beasts is a Cambridge-based hosting company. They provide all sorts of servers, one of which is a Raspberry Pi. So I'm logged in here, so this is what you get when you go to their Pi page. So you can choose to pay differently with different means. So you've got pay monthly, pay quarterly, pay yearly, and on demand. There's also an API that allows you to provision up Pis at your own will, which will default to the on-demand billing. So you can just deploy them and tear them down as needed. So I'm going to use that option for now. You can set the disk space you need. The default is 10. That's the sort of minimum, and you can add more and pay more for that. if you need extra space. So currently they just have Raspberry Pi 3s. They're a mix of Bs and B pluses, and it's random which one you get. I'm sure they'll that in future they'll add some Pi 4s to their collection as well, and they'll probably allow you to choose between the two. So if I've selected on demand, I've got my Raspberry Pi 3, 1GB of RAM, 4 cores. So you're not getting just a slice of Pi, you're getting the whole Raspberry Pi itself, dedicated Pi. The way this works is they're not booted from an SD card the way you would usually use a Raspberry Pi. They're booted over the network. So there's a server rack full of Raspberry Pis that are networked together. They're net booted using Pixie Boot on an IPv6 only network. It would be economically unviable to run every Raspberry Pi with a dedicated IPv4 address, seeing as an IPv4 address will cost you more than a Raspberry Pi. So they're all IPv6 only, but they do provide a bridge between the two. So if you're on an IPv4 network, so if you don't have IPv6, if your ISP doesn't provide it, they provide you a bridge that will allow you to proxy to get over to get directly to your Pi on IPv4. So you can get up and running really quickly. So if I've selected this, I'm just going to go order now. Okay, you're asked to provide a service name between 3 and 10 characters. So this just needs to be a unique identifier for your Pi, and you should bear in mind that if you're going to deploy a web app to this, it will be accessible at whatever you type as servicename.hostedpi.com. So I'm going to call mine tempgraph. So I agree to the terms and conditions, and you can fill out the rest if you like, and then go to confirm. So you're about to provision the following services. So yes, Raspberry Pi 3 called tempgraph, proceed. So this is currently being provisioned. So I've got there Raspberry Pi called tempgraph, Raspberry Pi 3, 4 cores, 1GB of RAM, terabyte of bandwidth a month, and disk space for the Raspberry Pi of 10GB. So that's currently telling me what it's doing. So it's currently installing the operating system, booting the Raspberry Pi. This is all happening in real time, waiting for the DNS to update, and it's done. So now I can click through, configure your server. So this is it. So this is all the details I need to get to it. So it's currently powered on, and it's running the default OS, which is Raspbian Buster. So if I want to SSH onto this, I use these details. So I've got the username's root, just gives you a root user initially. That's the host, so ssh.tempgraph.hostedpi.com on this particular port. So this is the port that will route you through to through the IPv6 proxy, so that you can access it from an IPv4 network. Alternatively, if you've got IPv6, if your ISP provides it, you can just SSH to root at this, and you don't need to go through the proxy. But a lot of people do. So, and it uses SSH-based authentication. So the only way you can get onto this currently, unless you log on, well, you have to log onto it once. Obviously, you can log onto it and you can enable password authentication. But I think SSH key authentication is a really good practice, so I keep it at that. And so this is the command I would need to do it. But first of all, I need to configure my keys. Open a terminal, and if I grab my SSH key from .ssh id rsa.pub, I'm going to grab the contents from that file. So that's my public key. I'm going to paste that into here and save changes. So now I should be able to use this command to log on directly onto the Pi. There we are. I'm now on my Raspberry Pi. So if I do cat proc CPU info, you can see there. This is that's the Pi serial number. That's the revision. You can see all 4 cores, And if I do cat proc device tree model, that shows me that this is a Raspberry Pi 3 Model B. So I didn't get a B plus this time, but that's a B. And that's it. That's my Pi. I'm going to first of all just run an apt update, and that will prompt me to update from this repository. So that's now updated the apt sources. So I'm going to install a few just useful tools that I'm going to need. So apt install. So I'm running as root here, so I don't need sudo. So I'm going to be using Vim as my editor. I'm going to use Biobu, which is a SSH shell manager, terminal manager, which will allow me to run several things at once and just skip over without needing multiple terminal windows. I'm going to use Ranger, which is a way to navigate around files really easily. I'm going to need Git because I'm going to clone the Anvil app, and I might need Tree as well just to show the contents of the file system. So I'm going to install those first. Okay, so that's done. And now I'm going to install the requirements of running an Anvil app. So I'm going to need apt install Python 3 pip, which will bring in, Python 3 pip, which will bring in Python 3 of course as well. And open JDK 8 JDK. So that's the Java Development Kit version 8. So let's install those as well. Okay, so that's done. I'm just going to do a couple more things. I'm going to grab my vimrc and install that so that I can see what I'm doing. And I'm going to enable Biobu. So Biobu enable. So I just log out and back in. So now I'm in Biobu session, so you can see along here, this is the Biobu sort of taskbar. So now I can run a command in here, and I can create a new window with F2, and now I'm on number 1 here. So I can run something else in here, like there, and I can switch back to the other window with F3 or F4, so F3 and 4 cycle between them. I can create as many of those windows as I want. And just close that one, I'm not going to need it, and go back to 0, but that will come in handy later. So I've got my Biobu session running, I've installed all the requirements, so now I'm going to use pip to install the Anvil app server. So Anvil recently open sourced the app server. It used to be that you could create an app in Anvil and they would host it for you and you could run it there. Now they've open sourced this bit. It means you can run the whole thing on a server of your own. So in this case, we're running it on a Raspberry Pi. So we've built the app in Anvil using the web interface. We're going to git clone it onto this Pi and we're going to run it on the Pi. So it's completely separate from the Anvil system itself. So this is a completely enclosed app that is completely hosted on the Raspberry Pi. That isn't relying on anything external. So that's installed the Anvil app server. Another thing I need to do in preparation is allow the user that this is going to be running under to have unprivileged access to run on port 443. So I'm going to be using HTTPS, so SSL port needs to be available. So they provide a couple of commands that you need to make this happen. So I'm going to echo this into here and just run this sysctl system. Okay, so now I've got permissions to do that. So I'm going to need to create the user that this is going to run under because I can't run an Anvil app as the root user. So add user Anvil will create me a new user. Give it a password. Don't need to give it a full name or a room number or anything. So now I can su Anvil and become the Anvil user. So now I'm going to go to my Anvil app, go to Share App, and to clone with Git, I'm going to need to provide an SSH key. So I need to run SSH keygen in here. That will generate me a public and private key pair. I'm going to give the public key to Anvil. So cat ssh id rsa.pub. Copy all of this into here. I'm going to copy this line, the git clone line. So I'm going to save that. So I'm now authenticated, and I can run the git clone command. So that will clone a copy of my app into my Anvil users home directory. So here, Pi temperature demo is this app here. So if I use tree, I can look inside there. So this is the entire contents of my app. So it's all in Pi temperature demo. I've got an init.py and an anvil.yaml. I've got a client code directory, a server code directory, and a theme directory. So my client code contains form1, which is the same thing here, form1, which contains an init.py. So if I click on form1, this code here, this is the init.py, and it also contains a YAML file for the form template. So that's the layout of the form. And then we've got server code, and server module 1.py. So this server module 1, this is a Python file. So it'd be a good guess to say that that's where the server code is. Then we've also got theme, which we've not touched. You can actually access the theme, the HTML and the CSS. We're just using all the bog standard stuff they give us, but you can modify that if you need to. So you can modify it here in Anvil and here when it's on your server. So now I'm going to see if I can run the app unmodified and just see if I can get the exact same experience I had when I ran the app in Anvil, but being hosted on my Pi. So to do that, I'm going to run the command anvil app server, and then I'll provide the name of the app. So that's Pi temperature demo. Now I'll let autocomplete finish it there, but I don't want the trailing slash, because you don't provide a path to the app location, you just provide the app name. And then that would normally be enough. If I'm running this on my own machine or I'm running this on my local network, that would be fine, it'd be running. But I want to provide the origin, which is the location I want it to run at, the URL. So I'm going to provide that as https www. Then the service name, so tempgraph.hostedpi.com. So I run that. So the first time you run this, it takes quite a while because it needs to download a jar that contains a load of stuff that it needs to run. But every time after that, it's much quicker. So things like the data tables. Now you notice I didn't install a database or anything, so that's all built into this jar. It's actually all running on Postgres. So what you can do is you can install Postgres yourself. You can apt install Postgres and manage it yourself, do it that way. But then you have to provide things like the login credentials and give the user permissions and things like that. It's actually just easier if you've got a standalone app like this that's just the only thing that's running, is to let Anvil worry about it for you, and it will initialize its own instance of Postgres and do all the connection and stuff for you, so it just works. So now you can see that's started up the server, so it's now ready to go. So now I should be able to access it on the web at www.https://tempgraph.hostedpi.com. Here's my app running. This is on the web. This is live. And if I go back to my terminal on the Pi, I can see things like the functions getting called on the server side. So calling function get hostname for app Pi temperature demo. get temperature, save temperature. You can see all the server-side functions being run, and they're run on this Pi. Now you notice that the graph just has a single point of 53, so it didn't actually, when I git cloned it, didn't bring a copy of the database with it. So it's initialized a brand new database on the Pi, and because I've only run this once, it's showing as it's just inserted its first value, which I left it being statically sending in a 53 reading. So it's just got the one there. So if I refresh, I'll see another result being added. So now I've got another 53, so it's just a straight line. So this is working exactly as it was before. If I hit joke, I've got some joke, and I've got all my server-side functions returning basic strings. But now that it's running on the Pi, I can actually write functions which return the real model number of the Pi and the real revision code and things like that, and also log the real CPU temperature. So let's move on to that. So I'm going to leave the app running and start a new BOB window. So if I press F2, it's still running. If I switch back with F3 or F4, I can see that it's running there, and switch back. And this is my number one window there is gonna be where I'm editing stuff. So I'm gonna just zoom back to the Anvil user there. So now in here, I've got my Pi temperature demo. So I'm gonna launch Ranger, and that will allow me to skirt my way around the project really easily. So this is where I'm at currently. This is the directory below, this is the directory above. So from here, if I go into, say, if I look at client code first, look at form 1, I'm just using left and right to navigate around and up and down. So client code, form 1, init.py. Now if I open it here, if I leave it here with this in the middle, I can see the contents of the file there. If I go down to the YAML, I can see the YAML file. But if I press right again, I'll go into that file. It will open my default editor, but I haven't selected my default editor yet. So it's currently selected to be Nano, but I installed Vim and I want to use that, so I'm going to press 2. So now it's opened that in Vim. Now if I quit Vim, it's going to take me back to where I was in Ranger. So quick fire Ranger tutorial there, but so now we've got this init.py, which is the code that we wrote in Anvil, but I can now hack this and it's running live. So I've got my my server calls here. So essentially I'm going to leave the client side code all the same. It's only the server code I'm going to change. So before I start modifying the server functions to send back real values for the CPU temperature and the Pi model and revision and things, I'm just going to test out each of those on the command line and in the Python shell, just so I know what to do. So first of all, the easiest thing to do is get the host name. So you can see that here is Raspberry Pi which is shown in the shell in the terminal prompt. But where is that stored? Where can I read it from? Well, it's in cat etc. So it's in etc. hostname. So there you are, Raspberry Pi. So I can just read that from Python. Simple enough. Now to get the Pi model, one way of doing it would be to look in proc device tree model, for instance. So there's the model. That's one way of doing it. Another way to get the lots of Pi information and also the CPU temperature is through tools provided by the GPO0 library. So I'm going to install that. And also we've got the joke button at the bottom, so I'm going to use the PyJokes library to give me jokes for that button. So if I open a new BOB window, this is going to be root, so I'm going to pip install GPO0 rpi.gpio just to make things easier, and also PyJokes. So I'm installing rpi.gpio just because that way GPO0 will use it as a pin factory. For complicated reasons, it's best if you have that installed, because then even though I'm not touching the pins, it needs to initialize a pin factory, and it will be a harder workaround to do anything else other than just install the default pin factory library rpy-gpio. So I've installed GPIO0, rpy-gpio, and PyJokes. So now I can close that and go back to here. So if I open a Python shell, so for instance, if I want to read the hostname from Python, that would be as simple as using with open, etc. hostname. So with open that file as f, print f.readline. They are Raspberry Pi, so I can easily replace my function with something that will return that string. If I want to get some Pi information, I can say from GPIO0 import Pi info. So there's a Pi info function provided by GPIO0. If I get the contents of Pi info and save that as Pi, if I have a look at Pi, so it's truncated there, but you can see that we've got the revision code, we've got the model, we've got the PCB revision, the date it was released, the chip number, and all sorts of different bits of information about this Pi. I'm not going to want to use all of these, but if you wanted to extend the app to show all of the available information, you could do that as well. So if I want one bit of information, I can just say something like pi.revision or pi.model. So yeah, all of that is there, really easy. What I can also do from GPIO0 is say from GPIO0 import CPU temperature. So this is a GPIO0 device. It's a bit like a temperature sensor, like a GPIO temperature sensor, but it's actually just reading the file interface and giving you that back, so it can plug and play with other GPIO devices. But if I create an instance of that, so CPU equals CPU temperature, and say CPU dot temperature, and that's currently 41.8. So I think that's all I need on that. And then the other thing is PyJokes. So if I import PyJokes, say PyJokes .get joke, number of days since I have encountered an array index error -1. Very funny. So that's my joke. So I can run that again, get a different joke, hopefully. So yeah, that gives you a random joke. Just got 2 in a row there. So I can use that as well in my server functions. So I've pip installed additional libraries that aren't available on Anvil, and I can now access those in my server code. So let's go back to the server code, back to Ranger, and go into the server code. So now, starting with the easiest one, I can say get the host name. Instead of just returning a string, I can say with open etc. host name as f, return f.readline. Now if I save that and refresh my app, so you can see we've got the sum fields there, we've got the dummy data there, and then we've got the real host name coming through Raspberry Pi. So we can change these one by one. So if I want the Pi info, then I need to import GPIO0 in the file as well. From GPIO0 import Pi info, and go down here, and in fact I want to create an instance of Pi info, so Pi equals Pi info, and then return pi.model here, pi.model, and the rev code I can return as well, so pi.revision. So now each of these is returning a string again, but they're actually coming from somewhere, they're not just dumb strings. So temperature, I need to do CPU temperature, so I say CPU.temperature, and I need to bring in CPU temperature as well, and create a CPU object, CPU temperature. So I've got my Pi info, my CPU temperature, Pi model, Pi revision, host name, temperature. Let's try that before we go any further. We'll refresh that, and I should have all of those text fields. So I've got 3B, I've got A02082, Raspberry Pi, and CPU temperature. Now my graph is untouched, and my button is still static. So let's just do the Pi jokes. So from Pi jokes import. Now I don't want to call this get joke actually, so I'm just going to import Pi jokes because this function is the same. So get joke wants to return Pi jokes .get joke. So refresh that, I should have my joke working as well. So the only thing left to do, assuming that works, is save the temperature at the right time, and to, in fact, save the actual temperature first. So let's just check that joke button. So joke and SEO expert walks into bar, etc., etc. That's working. So I'll try again. Should get a different joke. There we are. So that's working. So now, if I want to return the real, record the real CPU temperature here, I can say CPU.temperature. So now, if I run this again, now this is still running on init, so when the form loads, it will save the real temperature this time to the database and show me that on the graph. So before we were saving static values of 53, and now we're saving the real value, which is closer to 45, and that saved the precise number there down in the database. So we've got a load of static 53s every time I hit refresh. These are all the timestamps of that happening, and then we've got a real value of 53. So really I want to clear out the database and make it so that it, and also make it so that it saves the temperature every minute in the background, and it's nothing to do with launching the app, but the app shows you all the data that's available. So now I want to go back to my client-side code. So go back to my form, and I don't want to save the temperature here anymore, so I'm going to delete this. So I'm no longer going to save the temperature on form load. And then if I go back to my server code, so I've still got my function that saves the temperature, and now it's saving the, it's the real date time and the real temperature, obviously. But I'm going to make this, rather than a server callable, I'm going to make it a background task. So I'm just going to change this to server.background task. I'm going to configure the Anvil app to run a background task every minute that runs this function. So now that this is runnable as a background task, if I can spell that correctly, then I can do that. So if I quit this and go back all the way back to the anvil.yaml, so we haven't looked at this yet. So if you're doing this in Anvil itself, then, and you want to create a background task, then there's a nice GUI way of doing that. But in the if you're doing it offline in your own server, then you can just edit this YAML file. So I'm going to edit this to add scheduled tasks. And then a list. So task name, save temperature, time spec, and 1 every minute and at no particular specification. I just need to give that a job ID. So I'm going to create one just called log temp. So this is a bit like creating a cron job, so it's going to run my save temperature function from my server code, which is decorated as a callable background task. So save temperature at every 1 minute, at not a particular time, so just every minute, and the job ID I've just called log temp. So I presume if it shows up in the logs, I'll see log temp. So you just need to kill the server, so Control-C, the server running, run it again, and then it'll pick up your background task, and now you can see that it's been picking up, just picked up the last couple of minutes. It ran the background task, and you can see that in here. So you can see task save temperature for app Pi temperature demo. So that is it calling the function from, and you can see it running again there. So now that's running every minute in the background. So if we refresh there, we'll see some up-to-date values. But the problem with this is that it's still got my dummy data that I threw in initially. So I do want to clear that out. And eventually over time, I will want to, this will fill up to such an extent that it won't be able to load all of the data points. So if I left this running every minute for, a whole day or, well, more than a day, then it would fill up too much and the graph would be kind of meaningless, or it wouldn't be able to load. So what I want to do is clear out the old data, but then also do that on a regular basis. So I'm going to go back to my code. So in the server code, first of all, I'm going to, whenever I save a temperature, I'm going to run a function called delete old temperatures, which I'll define here. So delete old temperatures. So delete old temperatures. Initially, I will do this as a one-off. I'll just delete everything once so that it's just clean, and then I will update it to just delete based on time. So first of all, if I want to delete everything, I do a search. So I'll say old temps equals app tables dot temperatures dot search. Yep. Search. So that's all data, and then I get a collection of row objects back, and I can iterate over those. So now I can say for row in old temps row dot delete. Now this is indiscriminate, so it's going to delete all of them, including the very, very latest ones, but it's okay for now, so I'm not losing very much. So now if I save that, then the next time it runs, it will run this version and will delete out the old data, and it would just be left with the very latest one. But that's not very good long term, because I don't want it to delete every single one. There'll only ever be one entry in the database. So what I want to do is change that search to be specific for searching for old temperatures, which are more than a day old. So if I refresh this now, let's see if it's deleted everything yet. Okay, so now we've got a clean database. So I'm just going to comment this out for the moment and save, just so it can keep going without doing that. So now I'm going to change this to have some search parameters. So I'm going to search for based on a time. So first of all, I want to be able to say when that time is. So yesterday equals datetime dot now minus time delta days equals 1. I'm going to need to import that, so I've already got date time, but I want time delta as well. So now yesterday is a datetime object with that's exactly a day ago. Then I want to use specify datetime equals. So this is in my app tables temperature search. So my database search for date times, but not a specific date time. I'm going to use a query which will search for less than a particular date, so less than yesterday. So to do that, I use this Q, which is here on line 2, which is imported, so the query language. So I don't actually have to write any SQL, I can use the Python version. So I've got Q dot less than yesterday, and that's all I need. So now it will do a search where datetime is less than yesterday, and then it will iterate over those results, not all of them, and delete those results. So it will truncate, it will prune the old results from the database, the old records. So now I can uncomment my remove all temperatures. So now every time it saves a new temperature, it prunes the old ones first, but not all of them. So now I can exit that, and I can know that that's now running in the background, so that if I come back to this in an hour, it will have an hour's worth of data, and it doesn't have my old results anymore. But it won't have been pruning any old records because they're not gonna reach yesterday yet. But in a day's time, it will start keeping that down to 24 hours worth of data. Okay, just checking in here. It's been a few hours since I finished this app, so it's been running, collecting temperature data the whole time. It's been really stagnant, just sitting just below 45 degrees the whole time, all evening. I've just run a command which I happen to know likes to warm up the Pi a little bit. So I ran pip wheel numpy with a no binary option, so that it gets it from Pi, so it gets the source distribution for Pi, not the wheel from Pi wheels. So it's downloaded the zip version of numpy, and it's compiling it from source. So it's sitting there. That'll take 10-20 minutes maybe, but the CPUs are really going, so it's getting hot. So it's currently up at 61. If I refresh again, it might have just gone up a little bit. But yeah, we'll see a big spike in that, and then once it's finished building, it'll drop back down, and then when I check in again 24 hours after I started, we'll see that big spike in the history. So look, it's up to 66 now, so it's still rising, but it'll probably get up to about 70, and the throttle will kick in, and it will probably stay up about 70 for as long as it takes to build numpy, and then it will come back down. So there we are. So I'm back 24 hours later, and it's just coming up to 6 PM again. So I did this time yesterday, and you can see it started to prune the data. So there's 24 hours worth of temperature data here. We've got the spike that I showed around 9 PM, which was when I was building numpy. I did it again just recently, about an hour ago. So you can see that similar sort of spike of the temperature while it was building numpy. Some reason something happened around 1 PM, 2 PM. Not sure what that was. It wasn't me, but it's in a rack full of pies, so maybe something external caused that. But yeah, you can generally see the temperature being plotted there throughout the last 24 hours. So thanks for watching, and hope you learned something, hope you enjoyed it, and look out for more videos like this in future.